and after that equation of the alternating current. Okay, and average value of the current is 0, and these
Yes, sir.
things I have, and I have told you shortcuts also, how to use these shortcuts. Okay, so today we will discuss the one very interesting concept, that is the circuit theory. Sir, what is the meaning of the circuit theory? Basically, circuit theory means we will discuss a resistance will be connected with an alternating voltage source. Earlier,
Yes, sir.
earlier what we have a DC source like
DC
battery.
source. Yes, sir.
A battery is connected with with a resistor, with a
Yes,
capacitor.
sir.
Now we will discuss what will happen when a resistance is connected, with an alternating source.
Yes, sir.
Earlier a DC source was connected. So so basically three types of circuits we will have. One is we will discuss purely resistive circuit. So in that circuit, only resistance will be connected to the alternating voltage source. Second circuit, purely capacitive circuit. In that,
Yes, sir.
only the capacitor will be connected. In the third circuit, only the inductor will be connected. And after that, we will study series LCR circuit. So
Yes, sir.
in series LCR circuit, inductor, capacitor, and resistor will be connected in series with an alternating voltage source. So first, I will start with the purely resistive circuit. So what is so first see this circuit. Basically, this is a circuit in which the resistance is connected with an DC source. DC source means battery.
Yes, sir.
DC source means battery is there. So basically, this is a DC circuit. This is a DC circuit.
Yes, sir.
And now we are discussing the AC circuits. So in AC circuit, there will be the alternating voltage source. So now pure resistive circuit. Pure resistive circuits we will discuss. So here our resistance is connected with an alternating voltage source. This is
Yes,
the
sir.
alternating voltage now, because
Yes,
this is
sir.
changing with time. This is changing with time. And what is the source of the alternating voltage? AC source, like AC generator and all that. Okay.
Yeah.
So basically, this is the circuit. And already I have explained what is V, what is V naught, what is omega, what is T. So I have just written here all these things. Maximum V is the voltage at any instant of time. V naught maximum value of the voltage. Omega is the angular frequency. There is a relation between the angular frequency and the frequency. Omega is equal to 2 pi f. I am telling because these relation will be used here. Okay.
Yes, sir.
So V naught by R means maximum value of the voltage in this circuit is divided by the resistance is equal to the maximum value or the peak value of the voltage in this circuit. So basically we know na V is equal to IR.
Yes, sir.
V is equal to IR, we know. If I want to find the current, so I will write V divided by R. If I want to find the maximum current, so there is a maximum voltage divided by R.
Yes,
Okay.
sir.
Now, very important thing now we will discuss. Basically, this is a voltage source, alternating voltage source. So as alternating voltage, so voltage will give the current. Due to the voltage, there will be the current in the circuit. But
Yes.
we know that the current will be the alternating current. The current will change at after every movement in magnitude as well as direction. I have told you. So I am supposing that at any instant of time, the current here is I is equal to I naught sine of omega t. This is the current, and here is a voltage source is connected. Here is the voltage source is connected,
Yes, sir.
and this is a AC source. Okay, basically this is a alternating source, and we don't know the voltage equation. Suppose we do not know the voltage equation, but we know current at any instant of time, the direction of the current and the magnitude of the current. I is equal to I naught sine omega t is the current at any instant of time. What is
Instead of
I?
time.
What is I? I is the current
Current.
at any instant of the
Instant. Yes. Instantaneous current.
instantaneous current. This is clear now?
Yes, sir.
Okay. Okay. So now, just wait a minute. Water. Now see what we will
Yes.
do here. This is the circuit we have, and all these things we know. So here resistance is connected, so there will be some potential difference across this resistance. Alternating
Yes.
potential difference will be there. Okay, and this is the current at any instant of the time.
Yes, sir.
So in this circuit, what I am doing, I am applying the Kirchhoff's voltage law. I am applying the Kirchhoff's voltage law.
Voltage law.
Yeah, Kirchhoff's voltage law, that is KVL. KVL I am applying. So according to the Kirchhoff's voltage law, the summation of the summation of the voltage is equal to the, no, just wait a minute actually. We can calculate the voltage from the current,
Yes,
or we
sir.
can calculate the current from the voltage. Okay, so basically I am calculating from the voltage the current. V is equal to V naught sine omega t we have.
Yes,
Okay,
sir.
sine omega t we have, and this is the current, and the equation of the current we don't know. Okay, so we will apply the Kirchhoff's voltage law here. So current is I, and when we will apply the Kirchhoff voltage law, so we choose a direction na, to apply the Kirchhoff voltage law.
Yes, sir.
Clockwise direction I am choosing. So suppose you can start from any point. So at this point I am starting. So I am going in this direction. I am going in this direction. Okay. So when I am going in this direction, suppose this is negative and this is positive. Okay.
Yes, sir.
So the direction of the current is in this direction. So direction of current is from positive to negative. So this is negative at any instant of time, and this is positive. So these polarity will change with time. Why?
Yes, sir.
Because sometimes the voltage becomes negative. You can see sometimes become negative, then positive, negative, positive.
Yes, sir.
By the way, so when you will apply the Kirchhoff's voltage law, according to the Kirchhoff's voltage law, the summation of the voltage along a closed loop is equal to zero. Algebraic summation. Okay.
Yes, sir.
So from when you will move from here to here, so this will be the potential difference V. So you will take it positive. Why you are taking the positive? Because you are moving from lower potential to the higher
High
potential.
potential.
Now here is one another uh, potential difference. So now direction of the current. So current is going in this direction. So direction of the current is direction of the decreasing potential.
Yes, sir.
And what is the potential difference across this resistance? IR. Potential difference across this resistance will be I into R. V is equal to IR. No? IR is the potential difference.
Yes, sir. V is equal to, yes.
IR. So we will take that minus. So it will become minus IR, and if this is equal to 0. So from here I can write V is equal to I into R. V is equal to, and what is the equation of the V? V is equal to V naught sine omega
V
t.
naught
So
sin omega t.
yeah, we can write it here. V naught sine omega t is equal to current into the resistance. So from here we can get the value of the current, that is V naught by R sine omega t.
Yes, sir.
Now you can see here what is the value of V naught by R, that is I naught. So I can write the equation of the current. Instead of this V naught by R, I can write I naught.
Yes, sir.
So I can write I is equal to I naught sine omega t. Sine omega t. So basically, this will be the equation of the current in the purely resistive circuit. This will be the equation of the current in purely resistive circuit. Okay. What is I here? Instantaneous value of the current.
Yes, sir.
I is the instantaneous value of current in the circuit,
Yes, sir.
and I naught is the peak value of current, and omega and t we already know. Now see, this is the equation of the current and equation of the voltage what we have. equation of the voltage is V is equal to
V
V
naught
naught sine
sin omega t with
omega
t.
t. V is equal to V naught sine omega t we have. There is one another thing here that will be used, this omega t, this omega t and this omega t. Basically, this omega t, the angle, something which is sine, means the angle with
Yes.
sine is known as the phase.
See.
This is
Yes,
known
sir.
as the phase. PHA as the phase. This is known as the phase,
See.
and this is so basically this is omega t is the phase of the voltage, and here omega t is the phase of the current.
Yes, sir.
If I want to find the phase difference means phase of voltage minus phase of current, or you
Phase
can
of
say,
current. Yes, sir.
yeah, or you can say phase of current minus phase of voltage.
Voltage
We only find, we only want the difference. We only want the difference. So now see what
difference.
will happen. Phase
Yes.
difference is represented by phi, and I want to find the phase difference. So I have just applied here the modulus. Why I have applied the modulus? I will tell you why. When you will calculate the phase difference, what is the phase difference of V? Omega t.
Omega t. Yes.
What is the phase difference of current? Again omega t.
Omega t.
So you keep 0. So phase difference between the current and the voltage is equal to 0. In case of the purely resistive circuit. Okay. So why I have applied this modulus value? Because suppose I am writing 5 minus 3,
830.
mod of 5 minus 3, it will be 2. And if I am writing mod of 3 minus 5, it will become mod of minus 2, and mod of minus 2 is again 2. Basically, this mod will always give the positive value.
Yes, sir.
So that is why, because we only want the difference, that is why. So now you can say that the phase difference between the current and the voltage is equal to 0. So we can say the current and the voltage are in same phase. The current
Same
and the
phase.
voltage are in same phase.
Same phase.
The current and voltage are in same phase. So these equations of current and the voltage are very, very important. With the help of these equations, we will draw the phasor diagram, and I will tell you how to draw the phasor diagram in an easy way.
Yes,
Okay.
sir.
You have to just follow simple steps. Okay. So now we will draw the phasor diagram. Okay. We will draw the phasor diagram. For drawing the phasor diagram, the equation of the voltage and the equation of the current we should know.
Yes, sir.
So equation of the voltage we know, and equation of the current we know. Now, what you should do, see the equation of the voltage first. V is equal to
V naught
V
sin
naught
omega t.
sine omega t. Okay. So take two axes. Y axis and X axis we have taken.
Yes, sir.
After that, what you will do? After that, what you will do? See the phase of the voltage. The phase of the voltage is omega t. So basically, suppose if I am writing something like sine of 30 degree. So with sine, the another thing is angle. The another thing is angle. So omega t is basically a angle.
Yes,
Omega
sir.
t is representing some angle. So basically, when you will draw the phasor diagram, so you will draw the phasor diagram like this. From this point, you will just draw a line like this. Okay.
Yes, sir.
And the length of this line, is V naught. The length of this line is V naught,
V
and
naught.
this angle will be omega t. So basically, this is the phasor diagram for the voltage.
Voltage.
And if you will take the projection of this, okay, V naught on the y-axis, then you will get the instantaneous value of the voltage.
Yes, sir.
First step. Okay, so basically V naught I am writing here. Here I am writing this is V naught. Okay, this part is like this. Basically, this is the V naught.
Yes, sir.
See here, length of the arrow is this length of the arrow is representing the peak value of the voltage.
Yes, sir.
Okay, and projection on y-axis will give you the instantaneous value of the voltage. Okay, now see the phase of the current is also omega t.
Yes, sir.
Phase of the current is also omega t, and if you
Omega
want
T.
to write the equation of the current is equal to V naught divided by R.
Yes, sir.
So here the value of the current, because current is voltage divided by R. So current is less than the voltage in terms of the magnitude. So
Yes, sir.
current is less than the voltage. So if you will draw the phasor diagram of the current, and I have already told you current and the voltage are in same phase, are in
Same
same
phase.
phase.
Same phase. Yeah.
So we will draw the phasor diagram of the current like this. So this is the current here. This is the peak value of the current, and when you will take the projection of this on y-axis, you will get the instantaneous value of the current.
Yes, sir.
So simplest way to draw the phasor diagram. Okay. So basically, in your syllabus there is only phasor diagram. So
Yes,
just
sir.
I am telling wave diagram also for this circuit only. For the wave diagram, basically equation of the current and the voltage you should know. Equation of the voltage V naught sin omega t, I naught sin omega t is the equation of the current. So basically
Yes, sir.
both will be the sine curve. Both will be the sine
Sine
curve,
curve.
but the value of the voltage is greater. Value of the peak voltage is greater than the value of the current. So you will draw
Yes.
the sine curve for the voltage. So this yellow color curve is representing the voltage curve,
Yes,
and
sir.
this green color curve is representing the current curve. Why this yellow color is upper and this green color is lower? Because peak value of the voltage is greater than the peak value of the current. And
Current.
what is this t? T is the time period. What is this t by 2? Half of the time period. What is
Half of
t?
time period.
What is this t by 4? T by 4 is basically 1 by 4th of the time period.
Yes, sir.
So basically at this t by 4, no, at this t by 4, when you will see, you will get the peak value of the voltage. See
Yes, sir.
how you will get the peak value of the voltage. For calculating the value of the voltage at t by 4. At t by 4, you want what is the value of the voltage? Suppose at
Yes,
t
sir.
by 4. T by 4. So what is the equation of the voltage? V is equal to
V is equal to V naught
V
sin
naught
omega t.
sine omega t. And t is we have t by 4.
T by
We are
4.
calculating for t by 4. So it will be V is equal to V naught sine of
T
this
by
is
4.
omega, and t is t by 4. Now I have told you omega can be written as 2
So
pi
T
by
by
t.
4, right? You wrote T
Yeah,
by
it
4.
is just t by 4. Huh? Good. So omega can be written as 2 pi by t. So
Yes.
we can write this will be V naught sine omega can be written as 2 pi by t, and this is t by 4. This t and t will be cancel out. This
Answer
2 and 2 will be cancel out. So
pi
what
by
we will
2.
get? Pi by 2. And what is the sine pi by 2? 1.
1.
So what value we will get? V naught. What is V naught? Maximum value.
Maximum value.
So you from the graph also you can see that this value is the maximum value, that is V naught at t by 4. Same value you will get maximum value of the current at t by 4.
Yes, sir.
So this is very simple circuit I have discussed. Resistive circuit, purely resistive circuit. In purely resistive circuit, the current and the voltage are in same phase.
Same
The
thing.
current and the voltage. Simply, if
Same phase.
for the question when we will solve the question, so we will represent the this diagram like this in a simple manner.
Yes, sir.
Voltage and the current are in same phase.
Same phase.
Okay, so this is the voltage and this is the current are in same phase. This is a simple diagram. But if someone saying draw the phasor diagram, so you will draw this diagram.
Okay.
Okay, so first note down this, then we will discuss the capacitive circuit. And there we will see what will be the phase difference between the current and the voltage in case
Yes,
of the
sir.
capacitive circuit. So write down like this. Write down like this on your copy. First, write circuit theory.
Yes, sir.
Circuit theory, and you can write case number one. Case number one, and after then write pure capacitive circuit. Okay, in that way
Yes,
you
sir.
should do. So write down. So when we will discuss capacitive circuit, so we will see there whether the there will be the phase difference between the current or not, or
Yes, sir.
whether the both are in same phase or both are with the different phase. So when I am driving these things, we are studying the purely resistive circuit and capacitive circuit. So there will be a requirement of first trigonometry, and a little requirement of the differentiation, a little requirement of integration. So these three things, if you know, then you can get it 100%.
Yes, sir.
The time is running very fast.
ठीक है, scroll down.
Hmm. This phase difference is one of the most important thing of this chapter, alternating current. Phase
Yes, sir.
difference. This phase difference creates the difference between the current electricity and the alternating current chapter.
Yes, sir.
Hmm.
Done, second school.
Okay.
Second school.
Basically, there is no requirement of it. Just I want to show with the help of the equation also, with the help of the graph also, you will get same value at same time.
Yes, sir.
Hmm. Completed, Harsh?
So just a minute, sir.
Okay. So now after this, now before the capacitive circuit, we will discuss the inductive circuit. Circuit. We will connect an inductor with an alternating source, and we will see what will happen.
Done, sir.
Done. Okay. So first of all, this is okay. Till here it is okay, no problem.
Yes, sir.
But now inductor will be connected with an alternating source. So before that, you should know what is inductor. Like resistance, you know.
Yeah.
Resistance opposes the current, no problem.
Inductor
Now
flows with the current, sir.
basically resistor opposes the flow of the current.
Yeah.
But
This one
inductor
won't let the
is,
current pass through.
yeah, actually, sorry, inductor opposes the change in the current.
Yes, sir.
If you will increase the current, the inductor will try to decrease the current. If you will decrease the current, the inductor will try to increase the current. But
Yes, sir.
here the case is different. Here alternating current is itself a changing current.
Yes, sir.
So here alternating current is itself a changing current. So inductor, when you will connect the inductor will oppose, obviously. Okay. So inductor, what happens now when there is a change in the current, inductor develops an induced EMF. Okay.
Yes,
So
sir.
that the direction of the induced EMF opposes the increase of the current. So this is the case purely inductive circuit we will discuss. And you should know first what is the inductor. And these are the trigonometric things, values we will use during the derivation. So first thing and the foremost thing you should know this thing. If I am talking about only the magnitude. So this will be the EMF induced we have discussed, I think.
Yes, sir.
When there is a change in the current, I is the current flowing in the inductor. Okay.
Yes, sir.
So I is the current flowing in the inductor. This is the inductor. What is this? Inductor. And this
Inductor.
inductor, what is L? L is the inductance of the inductor.
Inductance. Yes, sir.
Yeah. So if there is a change in the current, the EMF induced in the inductor is equal to L di by dt. So inductor opposes the change in the current. I think this thing should be clear. This thing should be clear to you. So I am highlighting it. Okay. So this is one of the thing. After that, see this. See this circuit. Basically, this is the circuit.
Yes, sir.
And in this circuit, L is the self-inductance. This is the inductor. Okay, this is the inductor, and this inductor is connected with an alternating voltage source. This inductor is connected with an alternating voltage source. Suppose
Yes, sir.
initially, okay, see, this is the inductor, and all these things are clear. Suppose you have just connected this. There is no current in this circuit, and suddenly what happened? You have connected an alternating voltage source, and there will be the current in the inductor then.
Yes, sir.
And this current will be a changing current because this is the alternating current.
Yes, sir.
If this current is a changing current, so means you can say this current will also be in the inductor, and this current is changing, but inductor will oppose the flow of current. Inductor will oppose the flow of current by inducing an EMF.
Yes, sir.
So inductor will induce an EMF like this, so
Yes.
that there will be a current, induced current in the opposite direction.
Yes, sir.
Okay, now it's fine. So basically this first point you should know. And all the things I have written here, V naught peak value, omega angular velocity, T is the time, V is the voltage at any instant of time. We know already. Now, suppose E is the EMF induced by the inductor. E is the EMF induced by, and why the inductor is inducing an EMF? Because the current is changing.
Current is changing. Yes.
And this current is an alternating current, and alternating
Yes,
current always changes in magnitude and direction. You have seen. So this is E. Okay. So now we will apply here the Kirchhoff's voltage law. Suppose I am choosing this point. So when I will move, we will move in a circuit in clockwise direction, like this, like this, like this, like this, and like this. So from here to here, when I will move, there will be the voltage here.
Yes, sir.
So this will be the positive and this will be the negative. That is why the current is like this. So you can write this as when you will apply the KVL. When you will apply the KVL, so you will see here. Just a minute. You will see here that this will be V. This will be V minus, and here will be some potential difference,
Yes,
and
sir.
that potential difference is equal to the induced EMF by the inductor. So from
Inductor.
when you are going in this direction, you are moving from lower to higher potential.
Yes, sir.
That is why you are taking this V as positive. Okay. And when you are moving from here to here, means you are moving from higher to lower.
To lower potential.
Yeah, it will become V minus E is equal to 0. This is the Kirchhoff's voltage law. If you do not know, then you can go to the current electricity there and you can check there. Okay.
Yes,
If
sir.
you are not getting properly. So basically this becomes V is equal to E. V is equal to E. So this V is equal to E. Basically we should write E in this form, like small e. Okay, so this is also the small e. So V is equal to E. Now what is the value of the E? E is equal to L di by dt.
LD. Yes, sir.
Okay, L di by dt. Now from this equation, can we find the current? So di is equal to V into dt divided by L.
Yes, sir.
What is the equation of the voltage? V naught sine omega t.
Yes, sir.
And this is dt here, and this is L. So equation of the current is equal to di is equal to V naught by L sine omega t dt. So what is di? Di is the small value of the current or a small change in the current. What
Yes,
is
sir.
dt? Dt is the small change in the time. For calculating total current, you will integrate both the equations. And when you will integrate both the equation, why we use integration? For adding small values. So
Yes, sir.
total current in the circuit is equal to this V naught is constant, L is constant. So this will be out of the integration. So it will be V naught by L, and integration of, you will get sine of omega t into dt. Okay.
Yes, sir.
Sine of omega t into dt you will get. Now integration of sine omega t is minus cos omega t by omega. Do you know what is the integration of sine omega t?
Sine omega t.
So integration of sine omega t is equal
It is
to minus of cos omega t
minus cos omega t.
divided by omega.
Omega, yes.
Yeah. So okay, this. Now we can further solve it. So this is current and this is V naught by L. Sine omega t can be written as minus of
Minus of cos omega t by t, omega.
cos omega t by omega. Now this omega is also constant, so you can take this out of the bracket, so it will become V naught divided by omega L, and here is minus cos omega t. This is current I.
Yes, sir.
Basically, this V naught by omega L is the peak value of the current.
Yes, sir.
This V naught by omega L is basically I naught. So the equation of the current will become I is equal to I naught minus cos omega
Minus
t.
omega t.
So it will become I is equal to I naught minus of cos
omega t.
omega t. And what is the equation of the voltage we have? V is equal
V
to
is equal to V naught
V
sin
naught
omega t.
sin omega t. Basically, we want to convert this equation in terms of sin omega t.
Yes, sir.
Now what we will do? See, uh, 90 degree in degree there is 90 degree, in radian there is pi by 2 for angle. Remember this point. After that, you have to remember sin 90 minus theta, we can write cos theta,
Yes, sir.
or cos 90 minus theta can be written as sin theta.
Sin theta.
Okay, so there is no requirement of this. So there is a requirement of this thing. There is a requirement of this thing we have. So we will write here. So sin 90 minus theta is equal to cos theta.
Cos
So
theta.
cos theta can be written as sin 90 minus theta. And what is
Yes.
theta? We have omega t is here theta. So we can write cos omega t is equal to sin 90 minus omega t.
Yes, sir.
Very good. So now here there is no, here is, I am not applying the physics. Basically, this is the trigonometry. Okay. So now see, this is I is equal to I naught. Instead of this cos of omega t, I can write sin 90 minus omega t.
Yes, sir.
90 degree minus omega t. There is one more thing here you have to remember. Sine of minus theta can be written as minus sine theta.
Yes, sir.
Basically, see, if it is written that sine of minus theta, so you can write sine of theta. So what I want to say that if it is written that is a minus sign, if it is written that minus sine of 90 minus omega t, so it is equal to sine of bracket minus 90 minus
90 minus
minus
omega.
omega t. So this is the
Yes.
meaning. Okay, so this point you have to remember.
Yes, sir.
So basically now I can change it. So it will become I is equal to I naught, and this minus sine 90 minus omega t can be written as sine of minus
Minus 90
90 minus 90
minus
degree
omega t.
minus omega t. Okay. So further when we will solve it, we get I is equal to I naught sine omega t minus 90 degree.
Yes, sir.
Omega t minus 90 degree we will get omega t minus 90 degree we will get, and this is the equation of the current.
Yes,
This
sir.
is the equation of the
Current.
current we have. I is equal to I naught sine omega t, and what is the equation of the voltage?
V is
You
equal
can
to V
see
naught
here,
sin omega t.
sine omega t. So in case of the inductor, we have these equation of the voltage and the current. So basically now in case of inductor, the current is lagging. See what is the phase? Now there is a game of phase here. Omega t minus 90 degree is the phase of the current.
Yes, sir.
Phase of the voltage is omega t.
Omega 2
Now
pi by 2.
we will calculate the phase difference.
Okay.
Okay, we will calculate the phase difference, and when you will calculate the phase difference phi, what you will get? Phase difference when you will calculate phase
2 pi by
difference.
t minus 90 into minus 2 pi by
No.
t.
Phase difference phi is mod of phase of the voltage. What is the phase of the voltage? Omega t
Yes, sir.
minus phase of, what is the phase
Minus
of the current?
Phase of the current.
This value is
Minus
the phase
90,
of
right?
the,
Omega t minus 90.
yeah, omega t minus 90 degree. So
Minus
it will
omega
become
t.
omega t and minus omega t will be cancelled out, and minus
Yes,
minus
sir.
become plus. So basically 90 degree is
90
the phase
degrees.
difference. 90 degree is the phase difference between the current and the voltages in case of the purely inductive circuit. So you can, now we cannot say current and the voltage are in same phase. Now current and the voltage, current and the voltage are at a phase difference of 90 degree. But you can say voltage is leading the current. Voltage is leading the current by 90 degree, or you can say current is lagging
by 90 degree.
Yeah. Now we will draw the phasor diagram.
Yes, sir.
So here also I have calculated the phase difference. So I think there is no requirement of this. Okay, so phasor diagram we will draw. Now we will draw the phasor diagram. So we will have chosen both axes. This is suppose y axis. This is your x axis. So equation of the voltage we have V is equal to V naught sin omega t. Equation of the current we have V is equal to V naught sin omega t minus pi by 2. I have written in terms of pi by 2 because pi by 2 is 90 degree. And phase difference is pi by 2. So first equation of the voltage is equal to, first we will draw the phasor of the voltage. So how we will draw? Simple way, earlier also we have done this. So voltage is like this. Voltage is like this. This is V naught is the peak value of the voltage and making an angle of omega t.
Omega t.
Now current is leading or current is lagging? Current is lagging, lagging. Okay. So we will see how I will draw current is lagging. So this is the, now you have to draw the current such that the current is lagging behind by 90 degrees. So current is like this.
Yes, sir.
So basically this will be the current I naught and this angle will be 90 degree. Now you can see current is lagging behind by voltage by 90 degrees.
90 degrees.
If you will draw the projection, then you will get the instantaneous value. Here, if you will draw the projection, then you will get the instantaneous value of the current. So this is the phasor diagram. Okay, so you can see current lags behind the potential difference by 90 degrees.
90.
Okay. One more thing that I have not told you here, this V naught by omega L. V naught by omega L. This gives rise to
I naught?
Yeah, basically there is a term here known as the inductive reactance. So basically inductive reactance, where I should write, here is a space. So is it okay? Should I write here or here?
Yeah, you can write this.
Okay. So I can write here inductive reactance. Basically inductive reactance is represented by XL.
XL.
Yeah. So see this equation V naught by omega L.
Yes.
So we have I naught is equal to V naught by omega L.
Omega L.
And we know that the current is equal to voltage divided by the resistance something. Resistance,
yes, sir. Yes, sir.
So basically, this is the current, this is the voltage. So this thing will be something like resistance.
Yes.
And this omega L is known as the inductive reactance.
Inductance. Sir.
So XL is equal to omega L. So this point you should know. Okay. So this formula will be used again and again, and difference relation between the angular frequency and the frequency you should know. Okay, so this equation we have XL is equal to omega L, and omega can be written as 2 pi f also. So now we will draw the graph between the inductive reactance and the frequency of the voltage or the current.
Yes, sir.
Phasor diagram we have completed. So graph between the XL inductive reactance versus frequency. So we know that the XL is equal to omega L.
Yes.
And it can be written as 2 pi f into L. Now 2 pi is constant, 2 pi is constant, and L is also constant.
Yes, inductance is constant.
Yeah. Why constant? Because you have chosen the inductor. So for the chosen inductor, the inductance will be same.
Yes, sir.
So when you will draw the graph, so inductive reactance is directly proportional to the frequency. So basically, this type of graph you will get a straight line graph passing from the origin. You will get like you got in Ohm's law between the potential difference and the current.
Yes,
So
sir.
this type of graph you will get. This is the basically XL. This is the frequency. Okay, and okay, this is the graph you will get. XL is active proportional to F. So there is no requirement of this wave diagram. So now you can just write down this. So
Yes,
basically,
sir.
what you have learned here in this case, the main important things first equation you should know. Okay, and after that you should know what is the inductive reactance
Yes, sir.
formula you should know. After that, phasor, how to draw the phasor diagram you should know.
Yes, sir.
Okay, okay, you can now just copy this. Acha, what is this current I? Instantaneous current, na?
Yes,
I
sir.
is
I
the
is
instantaneous.
instance
So
current.
I
I
am
know the
writing
stake.
here. So I am writing I is the instantaneous current. I is the instantaneous current. I is the instantaneous current.
Seconds, hold on. Second scroll down.
Have you written these things, na?
Yes, sir.
Phase.
Yes, I have written this.
Okay, because these will help you a lot.
Yes,
Okay,
sir.
so write down. I am not saying this omega L is resistance. This is just like the resistance. Because
Yes, sir.
when you will see the unit of XL, when you will see, it will be ohm, like resistance. Okay, ohm.
Second scroll down. Done, sir.
Done. Okay, so write down this also.
Done, sir.
Okay, so one question I will solve. Then, if we will wind up. Okay, so that question is important. See, basically, what you have learned from this, the equation of the current is I is equal to I naught.
I is equal to
I naught. Just check in your notes.
I naught sine omega t minus 90.
Sine omega t minus 90. Minus 90 degree. Okay, and
Yes, sir.
what is the equation of the voltage? V naught
V naught sine omega t.
sine omega t, sine omega t only. Now remember one point: phase difference phi between the current and the voltage must be 90 degree.
90.
Whatever will be the, I am not saying. See, remember this point is very important. Whatever will be the equation of the voltage, not always you will get the equation of voltage V is equal to V naught sine omega t. Just because I have taken here, there can be any equation. Okay, so but main thing here you have to remember, phase difference between the current and the voltage will always be 90 degree. This thing you have to remember, and we will apply this concept in this question. In this question we will apply this concept. So this is the question. See this question. Sorry.
Yes, sir.
Just see the equation of the voltage and what they are asking. They are asking the equation of the current. Now see, they have not given the equation of the voltage like V is equal to V naught sine omega t. The
Yes,
equation
sir.
of the voltage is something different. You have to see the phase. What is the phase of the voltage?
10t plus 30.
Very nice. Means with sign you have to write the phase.
Yes.
With sign you have to write the phase.
Yes.
Okay. Now see, if I say phase of voltage, suppose I am representing it with phi suffix b. Phase of the voltage is given as 10t plus 30 degree.
Yes, sir.
Okay. Now I am writing phase of current. Phase of current. Suppose phi suffix I. Now what kind of circuit is this?
This is DC, right?
No,
Oh, circuit.
this is purely inductive circuit.
Yeah, purely inductive.
In purely inductive circuit, what is the phase difference between the current and the voltage?
90.
What will 90 degree? Okay, very good. 90 degree. So basically, okay, this thing is clear. So equation of the voltage is given. V is equal to V naught sine
Omega t.
10
10 t
plus
plus 30.
30 degree. Now, basically, what you have to do, you will compare this equation with the voltage equation. V is
Yes.
equal to V naught sine omega t plus some phase phi plus this is omega t. Okay. So when you will compare this equation, basically here instead of V naught it is 10 here. It is 10. This is 10. So when you will compare, what you will V naught, what you will get, what the value of V naught? V naught you will get 10 volts.
Yes, sir.
What I have told you in the starting, not always the equation of the voltage will be like V is equal to V naught sine omega t. Okay. So here phi
Yes, sir.
I is the initial phase. Phi I, suppose the initial phase. Initial angle, some angle. Okay. Phi
Yes,
is
sir.
so when you will compare, basically you will get V naught. Can you calculate I naught? I naught is equal to V naught by XL.
Yeah, I know we can calculate. Yeah.
So V naught by XL is equal to omega L. So V
Omega
naught.
L.
Okay. Now from here also we can find omega 10 radian per second. See, just calculate this. V is equal to V naught
Yeah.
sine omega t plus
Sine t, yeah.
this 10 t, and here will be omega. This will be omega. Omega is equal to 10 radian per second.
Radians per second.
So omega is 10. What is the value of the L given? I think L is given as 2 Henry.
Okay.
2 Henry given. So we will put L as 2 Henry, and V
2
naught is
Henry.
given. V naught is also 10. This is 10 into 2, 20. So basically, I current will be, you will get 0.5 ampere.
Yes, sir.
Now, when you will write the equation of the current, so how you will write the equation of the current? We know that in case of the purely inductive circuit, the phase difference of current is 90 degree
90
less.
degree less than the voltage.
Yeah. So when we will write the equation of the current, I is equal to I naught
I naught
sine.
sine omega
Then
t
phase,
minus 90.
yeah, phase omega t. Nay, you are right, omega t minus 90. But actually, you should write like this: this sign and phase of the current.
Yes, sir.
Okay, phase of the current you should write. Actually, phase of the current I have represented here phi I. Okay, just wait. We can write this as phase of current. So this is phi I, and I am removing it. I am writing it at theta. Okay, so this is any angle theta phi I.
Yes, sir.
Now phase of current you want, and you know the phase difference between the voltage and the current is equal to
90 degree.
90 degree. So phi B minus phi I is equal to 90 degree. Mod of phase of the voltage minus mod of phase of the current is equal to 90 degree.
Yes,
Is
sir.
it or not? What is the
Yes.
phase of the voltage? 10 t
10 t
minus
plus
30.
30. Yeah, 10 t plus
10 t
30.
plus 30. Very good. 10 t plus 30 degree
Yeah, minus.
minus phase of the current
Yes.
is equal to 90 degree.
90.
Okay. Now I can write this like this also. I can write this like this also.
Yes, sir.
Minus of 10 t.
Yes, sir.
Okay. Minus of 30 degree plus phi I. Okay. Is equal to 90 degree. This is a whole bracket, and this mod will give us the positive value, so it will become minus 10 t minus 30 degree, or
Yes.
it is becoming complicated. So basically what we should do, we should write it as 10t plus 30 degree minus 5i is equal to 90 degree.
90.
Now we can write it as 10t plus 30 degree minus 90, okay, is equal to phase of the current.
5.
So phase of the current you will get 10t
10t
minus
plus
60
minus
degree.
60.
So basically the equation of the current, finally you will get I is equal to I naught sine, I is equal to I naught sine 10t
10t
minus
minus
60 degree.
60.
But we can solve this question in 1 or 2 seconds also.
Yeah, the phase difference should be 90, so
90, yeah.
just subtract it from there.
Yeah. Actually, see here. This is the equation of the voltage we have.
Yes, sir.
Equation of the current will be I is equal to I naught. I is
Yes.
equal to I naught sine. Okay. Sine phase of the voltage minus 90.
Minus 90.
What is the phase of the voltage?
10t plus 30.
10t plus 30 minus
Minus
90.
90. It was minus 60.
So I is equal to I naught is 0.5.
Yes.
And this is sine. This
10t minus 60.
Minus 60 degrees. So in this way also we can. I have time, that is why I have told you. Otherwise, I will say do this like this. So because we already know the phase difference is 90 degree, and why we are doing these things, lengthy things.
Yes.
So, but this is just the method when you are not getting that. Okay. So in this way also you can find. Basically, both are the same method. I am not saying the different method. This is okay.
Yes.
Okay, so you can now
Done,
write
sir.
down.
I wrote it already.
Already. So, do you want that I should complete the